Hello students, today I'll discuss about strain. Previously I have discussed about stress. In stress I have considered a prismatic bar. So again I'll consider a prismatic bar of uniform cross section. A prismatic bar of uniform cross section, and it is having a length L, and I'll consider this prismatic bar is fixed at one end, and at another end I'll consider a force or an axial force or a tensile force P, fixed at one end, and it is having axial force at another end. That force is P. So if we are applying a tensile force, in that condition it will elongate the prismatic bar. So it means there will be some change in length happened in this prismatic bar. So because of that, what will happen? Because of that, the original length of this prismatic bar is L, and if we apply tensile force, in that condition it will elongate, or there will be some change in length in this prismatic bar because of axial loading. So we will consider this change in length is del L. That change in that particular length is L, and that change in length is L. So this change in length after application of tensile force is called deformation. So we can say deformation per unit length is called strain. Deformation per unit length is called strain, or deformation caused due to external loading is also called strain. Here we are applying tensile force in this prismatic bar. So first condition, if we are applying tensile force on prismatic or any kind of material, in that condition the strain developed, the whatever strain developed in that particular material will be a tensile strain, because it elongate the material, or it will elongate, if I am considering the example of prismatic bar, it will elongate the prismatic bar. Second condition, if I am considering compressive loading or compressive force, in that condition it will compress the material, or it will compress the prismatic bar. It will compress the prismatic bar. So in that condition the strain developed is called compressive strain. Compressive strain. And if the strain developed by shear force, if the strain is developed by shear force or shear stress, in that condition the strain will be shear strain. The strain will be shear strain. So these are three types of strain, and we are considering the original length of the prismatic bar is L, and the change in length is delta L, and if we denote that strain by eta, that will be equivalent to delta L by L. Delta L by L, it means if we considering all the dimensions in meter, so there will be meter by meter, so it will cross. In that condition the strain is the unitless or dimensionless quantity. Dimensionless quantity. Why? Because del L by L, del L is also having unit in meter, and the particular length is also having dimension in meter, so there will be strain will be a dimensionless quantity. So this was all about strain. Thank you.